Welcome to this special video. Subsequently, I'll be bringing out videos like this where I'll be answering questions that have not been properly answered in the past. I mean in past questions and answers pack, or questions that have been given by examination bodies without the correct answer in the options. Now, this is one of them. This is from year 2000 Utme and it's question 10. For this one, JAMB did not provide a correct answer. Now it says, what is the electronic configuration of this ion 22x2+? Now to begin, the 22 here is the number of protons. Usually, when we represent an element as X and we put A here, we say this A is number of protons as well as number of electrons. But in this case, it is number of protons, but not number of electrons because of the charge. And in the previous video, we already said that number of protons minus charge will give us number of electrons. So in this case, the number of electrons will be 22 protons minus the charge plus 2. So that minus times plus is minus, and 22 minus 2 gives us 20. So we have 20 electrons to deal with. However, the wrong approach would be to try to write electronic configuration for a species with 20 electrons. In that case, you'd end up writing 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. JAMB provided this in the options, but it's not the answer. To answer this question correctly, you need to write the electronic configuration of element number 22 first, and then the 2+ here tells you that it has lost 2 electrons. So from that electronic configuration that you have written, you will remove 2 electrons. So coming to this side, 22 electrons would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. Now what we have on the board is the electronic configuration for element number 22. Now this element is about to lose 2 electrons so that it gives us its ion, alright? Because x2+ is element X that has lost 2 electrons, so that it now has 2 excess protons, okay? So how do I remove 2 electrons from here? Note please, this 1 you are seeing here tells you that the 2 electrons up here are in the first shell. Remember, 1 is for first, so this 1 is for the first shell. We have 2 electrons there. 2, that's the second shell. How many electrons do we have there? 2 plus 6, so that's 8, like this. Alright, so I'll put 8. Then the third shell, what do I have in the third shell? Please watch. The third shell, this is third shell, third shell, third shell. How many electrons in all? Third shell, 2 electrons. Third shell, 6 electrons. Third shell, 2 electrons. That's 10. So in this third shell, I'm going to add 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Alright? Then there's a fourth shell with how many electrons? 2 electrons. So I'm going to draw the fourth shell like this. And out there I'll put how many electrons? 2. Now, if this element as it is to give out 2 electrons to produce its ions, it will give out the outermost electrons, so that once that outermost shell goes, what we have left is the ion of element X. Now remember that these 2 electrons are in the fourth shell. And where's the fourth shell in this expression? Here it is. So that's what we are going to remove. So that 22x2+ becomes 1s2, 2s2, 2p6, 3s2, 3p6, 3d2. That's our answer. Alright? So this is the correct answer to the question. And it works like that for transition metals usually. For example, consider iron, element number 26. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d, because it's 26 now, 6. Alright? Now, looking at this one, looking at this element, what if we're asked to write the electronic configuration of this guy, Fe2 plus? 2 plus here means that we're going to throw away 2 electrons. So where would we take our 2 electrons from? The outermost shell, which is 4 here. So the 4s2 will leave, and what you have left is Fe what? 2 plus. But what if it's Fe3 plus? After removing these 2, you can then remove one more from here. Okay, because 3d6 is next. So that we have 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. That would be the electronic configuration of Fe3 plus. That's about cases like this. Hopefully you'll meet more in the nearest future. Continue to practice, continue to watch my videos. Remember to like and subscribe. There's so much in store for you, all right? So as you watch, you like, you subscribe, and before you know it, you will improve. Thank you very much for watching this video.